Today in Math 10C we're going to start Chapter 2 on trigonometry. We're calling this 2A, naming the sides of a right triangle. If we look at a right triangle, well, this is triangle ABC, we're going to learn how to name the sides of a right triangle. Well, they've got three names. They're going to be the side that's going to be opposite the angle that we're considering. For instance, if we look at this triangle from angle A, side CB would be the side that's opposite angle A. Next, we're going to have the adjacent side. That's going to be side AB because that side's adjacent to angle A and it's not the hypotenuse. Remember, the hypotenuse is the longest side and the longest side is across or opposite our right angle, angle B. The hypotenuse always is the same. It stays the same in all triangles. What changes is the opposite side and the adjacent side depending upon which angle we're looking at the triangle from. For instance, in the other triangle, if we're looking at from this triangle from angle C, now side AB is going to be called the opposite side, side BC is going to be called the adjacent side, and the longest side that's opposite the right angle is always going to be the hypotenuse. So that's how you name the sides of a right triangle. Now there's three sides to a right triangle. That means that there's going to be three primary trig ratios. The ratios are going to be the lengths of the sides of the triangle. If I compared the opposite side to the length of the hypotenuse, that's called the sine ratio. If I compared the adjacent side to the length of the hypotenuse, that would be called the cosine ratio. Or lastly, if I compared the adjacent side, the opposite side to the adjacent side, I would have what they call the tangent ratio. Because there's only three ratios that can be had, because we can compare sides opposite to adjacent, adjacent to hypotenuse, or opposite to hypotenuse. And those are the three names. We remember them with something called SOHCAHTOA. SOHCAHTOA means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's just a little something to help us remember the three trig ratios. In examples, we're going to do is this first one. In triangle DEF, we're asked to name the sides in relation to angle D. Well, in relation to angle D, FD is the hypotenuse because it's opposite the right angle E. Next is side DE. Side DE is not opposite angle D, so it must be adjacent. And EF is going to be the side that's going to be opposite. In your turn, I'm going to ask you to find, in relation to angle C, the name of those three sides, and in angles DEF, in relation to angle F, name those three sides. Okay, using the trig ratios of sine, cosine, and tangent, we're going to use them to find the missing side lengths of triangles. Remember SOHCAHTOA, meaning that sine of our angle is the opposite side compared to the length of the hypotenuse. The cosine of our angle is the length of the adjacent side compared to the length of the hypotenuse. And the tangent of the angle is the length of the opposite side compared to the length of the adjacent side. In example 1, we want to find the length of side X. Notice that we have a 60-degree angle given, and the length of the one side is 12. So here's the steps. Step 1 is to identify the sides that you're working with. Well, the 12 is the adjacent side, the X is going to be the opposite side. So now we can say, step 2, ask, which trig ratio do I need to use? Well, from the three that I have, the only one that uses the adjacent and the opposite side is the tangent ratio. because the tangent ratio was going to be the length of the opposite compared to the adjacent. Now, that means that the tangent of 60 degrees, because that's our angle, is going to equal the opposite, which is x, over the adjacent, which is 12. Now, step 3 is going to be to solve for x by cross-multiplying. And what we're going to get is put that one side, or the tangent of 60 over 1, to cross-multiply. 1 times x is x. 12 times the tangent of 60 is on the other side. And 12 tan 60 is approximately 20.8. That's have it. That's how you figure out the length of a missing side. In your turn, we want you to go ahead and find the length of side x in these two triangles. And then we're going to correct them later. Okay, now we're going to use the trig ratios of sine, cosine, and tangent to find the measure of missing angles. So here we have two sides given, and now we're asked to find the angle between those two sides. So what we're going to first of all say, step 1 is to identify the sides that we're working with, just like before. Well, the 31 is the hypotenuse, and 12 is the adjacent. That means if I looked at SOHCAHTOA, the adjacent and the hypotenuse, I'm not using the opposite side. So I'm going to cross out the two trig ratios that are using the opposite side, and I'm left with the adjacent and the hypotenuse and cosine. So cosine of our angle has to be the length of the adjacent side compared to the length of the hypotenuse. And how this works is it has to be 12 to 31. Now the ratio of 12 to 31, if I go 12 divided by 31, I'm going to get 0.3871. What that's telling me is that there's only going to be one angle that's going to give me that ratio of those two sides. If we know that the ratio is 12 to 31, or 0.3871, we can determine the angle that makes this ratio. Now this is stored in your calculator or in a trig table, and if you enter in the cosine inverse of 12 divided by 31, you will find that the only angle that can make a ratio of this size is 67.2 degrees. That's how we're going to use trigonometry to find the missing angle of a right angled triangle. Your turn. Find the missing angles of these two triangles, and we're going to correct them later in class. Your assignment is page 95, numbers 7 to 10, and page 101, numbers 3 to 6. This lesson covers everything that you're going to learn in topics 2.1 to 2.5.